Today we're going to do a little bit of GameCube homebrew via soft mod. Now, something that really hasn't been explained entirely is, what is a soft mod? A soft mod is a way of using over-the-counter products and a lot of software manipulation to load some kind of flaw or exploit or some kind of something that is vulnerable inside a console's hardware that will allow you to load your own code. Whether it be homebrew or for bootlegging, it's morally up to you. The GameCube is no different. I think so far the only system that's not vulnerable to some kind of soft mod is the Dreamcast, because we can natively boot Dreamcast discs in a Dreamcast. We can make our own discs. But why can't we make our own GameCube discs? And this is something that you're gonna start noticing a lot with newer consoles. Now, the way the GameCube works is, it uses standard DVDs, yes. It's literally an 8cm standard DVD. There's nothing special about it, it's just a fucking DVD. The same DVDs you put in your Sony Handycam or whatever mini DVD, camcorder you may have that burns directly to disc, you can put directly into a GameCube. Great. GameCubes can also read standard DVDs. The problem is the case is too small and you can't get a full-size disc in, but next episode I'll show you the hard mod where you can get them to fit. However, this is where the similarities with standard DVDs, the GameCube, will end. Now, how does GameCube or Nintendo prevent you from copying GameCube games? And this is where the data layout of the disc is completely complicated. Now I'm going to try to rough it up for you, I'll try to slim it down, but how it works is, instead of the data being written from the inside of the track outward, like most discs, it's actually written from the outside of the track in. There you go. Now, another thing is, within this data, now the disc has to be exactly 1.47, I believe 1.47 gigs in total size. It cannot be any more, it cannot be any less. The reason being is the data that's on the disc is in something called a data frame. It's how the data is laid out on the disc. I'll put some show notes up, and I'll try to put some links so we can explain a little bit more about the data frames and such. But anyway, as the data is laid out, doesn't matter how big or how small the game. It could be 50 megs or it could be 1.4 gigs. The bottom line is there's scrambled data that fills up the entire disc, and this scrambled data goes through a form of XOR cipher stream. Now, XOR is a form of Boolean algebra or computer algebra. And this XOR table has a seed that's generated within the disk structure somewhere that we have not been able to figure out yet. We don't know how to decrypt it yet. But within the disk itself is the seed key on how to decode the XOR table. So when you put the disk in, the GameCube will look at specific spots on the disk to check both the size of the disk and two or three different spots on the disk at specific addresses for the XOR cipher stream. And each disk is completely different. Now, if you take a GameCube disk and you look at it at a certain angle, you'll notice a barcode around the side. And I do believe this is called the burst grid area, or the BGA area. And the GameCube knows how to read that barcode, and that barcode actually tells the cube, okay, this is where you need to look for the actual XOR cipher stream decode data. And that's something a standard PC can't read. So first off, a PC cannot read the data backwards. It can't read the BGA area properly. And even if it could not decipher the ciphertext coming off the XOR stream. So the computer just sees it as garbage data, makes it think that the disk is just scratched to hell. So that's how GameCube discs work. And it's very difficult for us to create, if impossible, right now as we're recording this segment, it's impossible for us to actually create a disk that has an actual XOR cipher stream, because first off, we can't write that barcode around the disk. Most burners, if any commercial burners, just can't do that. And we can't get the XOR data on there properly. So how do we authenticate the session? Now, there's two ways of doing this, through a soft mod and a hard mod. Next episode, I'll show you the hard mod method. In this episode, we're going to focus on a soft mod. Now, the soft mod, what you're going to need is something called a GameCube SD card adapter. This you can buy them on eBay for about 15 bucks. It's called the SD Gecko, or you can build one. If you actually remember episode 8, when I was building PCBs, I was actually building one for myself, this exact thing. You're going to need an SD card. Size doesn't matter. You will not be booting games off this thing. Don't try. It cannot be done yet. And we're going to need an Action Replay. Now here's the thing about Action Replay. Action Replay is actually produced by Code Junkies in cooperation with Daytel, and they're fucking scumbags because they have been ripping off all of the open hardware and open software of the homebrew community forever. Point being is, I have an Action Replay version 1.14. I'm not sure what version they're up to right now. You can go online and probably check. But point being is, my shit came with this card, and this card holds all my codes. And that means the Action Replay, the way the soft mod works is we're going to put this in memory card slot A, and we're going to put this in memory card slot B. We're going to put in the Action Replay. We're going to load up a custom code that's going to save to the card, and the card is going to tell the GameCube to boot code off of this thing. Classic soft mod method. You get your code, you get a bootloader. Bootloader exploits something, loads code off of a memory card or a USB thumb drive or some shit like that. Problem being is that because Daytel are corporate monsters and they're gluttonous, money-hungry assholes, they have removed the add code function, and they've even removed this entire piece of hardware. So what this means to you, the homebrew enthusiast, is you can't add the code that you need to this thing. So if you're going to look for an Action Replay, make sure it comes with this card. It'll show you directly in the bubble packaging. This card should be there. If it's not, put it down, walk away. But the reason they did this was so they can make their own version of their own soft mod. That's right. Daytel took the open source software of SD Load, which you'll see later, and they took the open information on the SD Gecko, and they have marketed to create their own piece of shit, doesn't work for crap, proprietary, bloated chunk of shit. Yay, Daytel. Good job at being scumbags, you fucking assholes. But, either way, if you can get your hands on this, you can get them off eBay pretty cheap. You might even have them laying around the house. It doesn't take much to create a PCB for the SD card. And to tell you the truth, what I do is I pop my SD card on. You can just trace these tracks and then use this shell. Just go and take a file and just etch away this over here, so you can go and make your own adapter. It's not very difficult, really. If you've paid attention to episode 8 and some of the electronics projects that we've been doing, you can easily go and get an SD card here to fit in here. Just a matter of just swapping out boards and doing a little bit of filing. But anyway, enough of bitching and moaning. Let's get to the actual GameCube side so I can show you how this soft mod shit works.
Okay, now of course we're going to need an SD card, and the SD card's going to need a little bit of work before we can get it going. The first thing you need to do is make sure you've formatted it with the FAT file system. Okay? The second thing you're going to want to do is you have to go and make sure you copy over a couple of DOL files, otherwise you have no homebrew. And I've got some DOL files laying around, I've got some loaders and whatnot. You're going to have to copy over a program called sdloader.bin. Do not rename this file, keep it all caps. Now, once you actually copied over your homebrew and once you copied over sdloader.bin, you'll notice that we have sdpatch.exe. Open up a command window, and you're going to want to type in sdpatch.exe and then type in the card letter, which in my case would be F:. Now once you hit enter, it's going to say the SD card has been patched successfully, and the file system on it should remain completely functional as before. And you may now proceed to the next step of the Action Replay SD card bootloader installation process. What this has done is it has actually put on the master boot record to actually boot native code off homebrew code for the cube off the SD card across GPIO pins. So what we're going to do is we're going to go ahead and select this SD card inside the SD Gecko memory card adapter, and we're going to go to the Action Replay side, and we're going to go and load up SD load and some of this bitchin' homebrew. Here we have a standard GameCube booting up. We've got Action Replay version 1.14. We got the SD card in memory slot A and the Action Replay hardware in slot B. You can determine what version of Action Replay you have by looking at the center ring on the disc itself. You look at it, reflecting off of a bright light, and there'll be a hologram that tells you exactly what version you have. So, go to your Action Replay codes, choose your region, and create a new code called SD load. You're going to have to put in a 3-line master code, and anywhere from a 29 to a 30-something line actual code itself. It's a very long process. Now there are 2 codes that you have to use depending on what version Action Replay you have. Now, this is a long, tedious process. I would suggest grab a beer, take your time, and do it right the first time. Check, double check, and triple check your work, because one mistake will create lots of problems for you. So once you have everything up and running and you got that code saved to your hardware, hit your start button, and your GameCube is going to order you to open the lid, and you will obey. Put in an original game, any original game. The actual action replay itself will do just fine. Close the lid, and it's going to execute the code, which is going to tell the GameCube to load sdload.bin off the SD card in slot A. And lo and behold, like magic, there's SD load. There's all your GameCube DAW files executable straight from your SD card. Now, at any time, you can pull this SD card out and put new files on it, put it back in, and it will refresh. Now, I'm not going to go ahead and explain all the homebrew I have on here, because that's what the fun of all this is. Going ahead and find out what works, what doesn't, what sucks, what rocks, and what floats your boat and what sinks your battleship. The one thing I do want to show you, which definitely floats my boat and sinks my battleship, is GCOS version 1.5, GameCube OS. This is a disk loader. It has a whole bunch of fun tools in there. I'm not going to get into the discrepancies of every little function of it, but it tells you what BIOS you're running, what revision, what drive model you have, the status, and what kind of drive firmware patches you might be running. You can boot an original game, you can boot a backed up game, you can also boot your own games, or your own homebrew games, and your own homemade disks with an assload of DAW files on them. In the tools section, you can back up your original games to an ISO. If you have a broadband adapter, what it will do is you put your disk in, it'll point you to an HTTP server that it will run on the GameCube and tell you exactly where to go to point your file browser. Use Internet Explorer over Firefox. Internet Explorer has less issues. Don't know why. They're working on it. But either way, you can back up your original games. You can boot your real IPL or your original BIOS. You can go to a Disk Explorer, which will allow you to put raw files straight onto a disk and boot those files from disk. So if you don't have to keep going to the SD card every single time you want to boot something new, you can go ahead and put 1.4 gigs worth of files straight onto that 8 centimeter disk. Or if you have a modded case, you can go up to 3 gigs on a standard 4.5 gig disk. Now, you can also set up a server on your network side and browse files across your network, so you won't even have to burn disks or put shit on your SD card. You can just go ahead and do it over LAN. Now, there are other loaders, and there are other ways of getting code to run on your cube, but remember that piracy sucks, because the XOR stream data is really hard to pull off disks, and the original games that were dumped weren't dumped properly, and you'll have a bitch of a time getting them to boot. So if you're going to go and be some hardcore piracy kitty, the bottom line is, if you're going to do bootlegging, pirate the games yourself. They'll be a little bit more reliable than relying on someone else to dump them for you. Not that I speak from experience or anything.
You may or may not know what this is. If you remember episode 8 of BSOD, Fox and his 2 gay daddies showed us how to make an Xbox to USB cable. Normally you use this to plug your Xbox controller into the computer to play games with the Xbox controller. But today we're going to show you how to use your Xbox DVD remote to control Windows Media Player on the computer, or any other media player you choose to use. Basically, you get one of these Xbox DVD remotes. They're off eBay for like $7-8 or so. A hell of a lot cheaper than a remote control you'd buy specifically made for the computer. Take the infrared receiver and plug it into your Xbox to USB cable. Easy enough. Now go over to the computer, and we're going to need to install some software. You're going to need to download a piece of software called Xbox CDRC. Once you have the program downloaded, double click it and go through the normal install process that you would deal with installing any software. Once it's done, go and start up the software. And once it starts up, I click the raw data box so I can see the actual code's gone across. And now you plug your Xbox receiver into the computer. Okay, like I said, check the raw data box. That way you can see if the remote's actually responding. If you look at the screen, we hit buttons, and you see the raw data is actually changing when we press buttons, so we know the remote's responding. So we want to open up Windows Media Player. We got some songs queued up, and hit play. See? Fast forward. And let's stop this. So, as you can see, now we got a, for $8, we got a remote control for our computer. So I hope you enjoyed this segment. Check the show notes. We'll have links to the software and maybe some tips so that you don't run into as many problems as I did getting this running.
Hey everybody, I'm Darts, and this is an intro to C++. So, C++ is a high-level language, which the short answer means that it needs a compiler to communicate directly with the computer. That means just writing all your instructions out and then compiling it with the compiler, and then you'll have an executable file. So, anything else you can figure out yourself on Wikipedia or Google the rest, but let's get it right into the syntax. So we have the double backslash, which is a regular comment. It's a full line comment. So you can start at the beginning of the line, or you can start, say, right here with just a couple of double slashes, and the rest of the single line will be commented out. Now this is a long comment. See, it's the backslash star, and then it goes until star backslash. I have that demonstrated up here. So I've got new lines here, but since it's in a long comment, then it's all commented out. Now it's useful for commenting out big blocks of code during debugging. So the first assignment that the compiler is going to see is include IOStream. Now this include statement, which is _include, is going to tell the compiler that it needs to go out and look for a file called IOStream, which it's going to immediately look in the where it knows already where the standard libraries are. So it's going to take IOStream and append the entire file right here. And that includes a lot of definitions and functions and stuff for input, output, variable manipulation. It's a really powerful tool, because I would hate having to declare everything from scratch at the beginning, and I know you would too. So, after the include statements, usually comes what namespace you're using. In this case, it's std. For the most part, you're going to use std. That's the standard libraries. It helps the compiler to know where to look for all our instructions. You know, it's scoping everything to the standard libraries. Instead of having to declare it each time where it's going, this automatically makes it know where it's going. Really, this only comes into play when you start writing your own and you have to make your own namespaces. But, well, you'll see later. Just right now, using namespace std. Nope. At the end of each regular instruction, declaration, or whatnot, is a semicolon. This denotes to the compiler that it is the end of the instruction. Do it, now move on. Here we have int main. Now ignore the int for now, but main, the main function, it's home. It is where everything is executed from your program. It is the function that the compiler looks for so that it knows where to begin actually, designing the instructions for the executable file. So everything in here, function calls, declarations, input-output statements, whatever you do is going to actually be seen first. So, no, it is a function. It requires curly brackets. There's an open bracket and a closed bracket. Like I said before, we have the type declaration int. That is an integer. It's going to expect to return an integer value. Now we'll get into return statements a little later as well, but basically it sends the value back when it's called. So if this were a private function and you had variable equals the call to the private function, you'd return something. In this case, we'd return 0, so it would be kicking back, and the value would be 0 for whatever variable you had the function equal to. But let's get into a little less complicated stuff. An int var semicolon. This is a variable declaration. Variables are integers, decimals, float point, character, and I think even string. In C++, you can also make your own variables and your own structures and everything for it. But these are the ones that are built standard into the C++ libraries. So we have our integers, var, and math. Now the compiler is going to take these and have it set aside 2 memory locations when the program is started. When you execute the program, it's going to say, okay, we've got 2 locations in memory, 2 integers, and it's going to handle where those integers are and where they go and what happens to them on its own, according to your instructions. It's a lot easier than actually handling the instructions themselves. So cout, which is an output statement, tells us please enter an integer in a string format. So the string is denoted by these double quotes you got and a semicolon at the end of the line. And what this is going to do is take the cout statement, it's going to compute all the things on the other side of these redirectors, which in this case is just a string, and output it to the screen. Then it's going to move on to the cin, which is an input. Note the opposite direction of the redirectors. And we have denoted var, which is an integer, so it's going to expect a keyboard input of integer from the user. And it's going to take that value and store it in the memory location that is associated with var. So, and then I have another cout statement. Note, I can have more than one output on a single cout statement as long as I separate them by redirectors. So I have a string variable var, which is now whatever value the user set for it, and an endline call, which carriage returns all this stuff, goes back to a new line. So what it's going to do is it's going to output the you entered and the value for var, and then go to the next line. And of course, semicolon at the end. These semicolons aren't actually shown, they're just to the compiler. So this is an assignment statement, and I just cut myself with a typo. Okay. Math is equal to var plus 5 semicolon. Now the easiest way to remember it is the stuff on the right is computed and then stored on the variable on the left. So var, which is whatever the input from the user was, plus 5 equals math. So math now has the value of var plus 5. An example, if I had 4 input here, math would equal 9. And then I confirm that I have cout redirectors string, I have the math variable, so it's 5 less, math is 5 less than variable, well, math is 5 more than variable, so 5 less than math. And then I have inline, and notice there's nothing here, but I continue. This is because, again, the compiler just totally ignores white space. So I can do that and not worry about it going all crazy on me. Like, obviously an enter right here would, mess up the formatting, but it won't break it. So, again, the return statement that we discussed, and the close bracket for the main function. So that's it. Let's go over to the console side and see what's up. I have a console-based compiler called G++. Pretty powerful compiler, I really recommend it. And I have the program's name, which is introbsad.cpp, an inline command of -O to designate a specific output file, BSOD. And that was successful, so we're going to run our program called BSOD. And we'll enter the integer 5, and there you go. Because the program first started by outputting please enter an integer, and then waited for input from me, which I put in 5 and hit enter. So it spat out you entered 5, and then did its math, and then spat out which is less than 10. And the statement I can do math. So that's C++ then. If you have any questions, hit me up on IRC, and I'll be making show notes available, and also put the program that I wrote up there, along with some sample output. So, later everybody.
In this segment, I'm going to show how to make a modified 2.4 gigahertz video receiver. I've already showcased the not-so-original, although interesting idea of creating a portable video scanner. This is mine. This is a 2.4 gigahertz video receiver that has auto scan features, a whole bunch of other crap. I like it. Modified with a panel mount end connector coupled into a 15 decibel gain helical antenna using a Game Boy Advance as a primary screen, a 9.6 nickel metal hydroxide 1.6 amp or 9.6 volts at 1.6 or 1.8 amp. Either way, this is my setup. Yours may differ, but what do you need to know to actually modify a video receiver? Well, first off, you have to understand that it runs off the 2.4 gigahertz frequency, and that is what we call a microwave frequency. Frequencies have names: UHF, VHF, super high frequency, blah 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 blah. This is microwave. So that means you need to have coaxial cable, the type of cable to carry that frequency to your device that's rated for microwave. Now, this is RG6 coax. This is commonly used in satellite and cable TV installations. You see this? This is 75 ohm coax. This is completely wrong. Do not use RG6 or RG8 or RG58. You have to use microwave class cable. No, niet, nein, no, stop, forget, no RG8, okay? No RG6, don't use it, for the love of God, no. Whoa, did I mention? No, you can't use it. What can you use? This is LMR 400. I have to personally thank both Dave and Andre Croy. Dave helped me out by obtaining the appropriate radio connectors, and Andre Croy helped me out getting the cable. LMR 400. LMR stands for Land Mobile Radio. This is microwave cable. This is designed for in excess of 6 gigahertz. We're operating at 2.4, so this is good. The problem is, it's stiff, it's bulky. How in the hell are you going to attach this bulky cable to something that has such a small little piece of coax coming out of it? Well, that is where lower diameter LMR 195. LMR 195 is thinner. Now you might be saying, okay, what's the big deal? Why should I care about what coax do I use? Okay, coax is like a pipeline for water, okay? It's going to carry your signal, and if your pipeline has holes in it, if your hose has holes in it anywhere, that water is going to leak out. So if you use RG6, RG8, RG58, RG58U, any of the other lower frequency cables, your signal is going to leak out of the side of it, and you're going to get signal loss. Significant amount of signal loss. And your signal is measured in decibels, or dBs. Now, having a thicker coax means you'll have less loss. The problem is it's bulky and it's unwieldy. It's very difficult to go and run short lengths of this because it's so unwieldy. But the thicker stuff is good for really, really long runs. The thinner stuff is good for shorter runs. All of my handheld devices that I'll be showing you how to mod and create in this series will be either using LMR 400, LMR 195, LMR 100 or LMR 200 coax cable, primarily LMR 195 and LMR 400. They are the two easiest forms of microwave coax that you can get your hands on. I'll try to put some show notes up on where to get it. We'll get into that later. I think I've explained enough about coax. So, you got your hands on some coax, how the hell are you going to go and connect it to your device? And let's go to the table side and I'll explain RF connectors themselves. Again, I'd like to personally thank Dave and Andre for getting me a lot of these connectors and the coax cable that I'll be showcasing. But with enough ass kissing, let's get on to the connectors and such. Okay, let's start out with some commonly used stuff, okay? Here's my Linksys router. My Linksys router has something called an RP-TNC, or reverse polarity TNC, okay? I've got an RP-TNC adapter around here somewhere. I got so much crap. Here we go. Here's the mating end. Now, I really don't feel that I should have to explain male and female to you. Really, you should have an understanding of the difference between what male and female is. You know, what boys have and, you know, girls don't, and vice versa. So, this is a reverse polarity TNC. This is a reverse polarity TNC. But I don't feel like making custom reverse polarity TNC antenna cables just for this. So I bought an adapter. And this is going to turn it into an end connector. Here is another end connector. This is called a panel mount 4-hole end connector. They also come in a 2-hole variant, which I didn't purchase because I don't care. This is another form of panel mount, but this one is designed to crimp onto LMR 195 cable. And here's its bigger brother. This one crimps onto the actual coax of LMR 400. We also have something called panel mount. Now there's a little nubbin and a little nut where we're going to be using this little guy later to build some antennas. Now we've also got reverse polarity SMA, as well as the mating connector for the coax. Now this has a crimp collar for LMR 195. This has a crimp collar for LMR 195. So what we'll be able to do is, by taking this connector, we're going to crimp it onto some cable, and then solder that cable leading into the RF box of a video receiver. Before I move on too far, Wi-Fi card. See those tiny little nubbins? See, those are called high-rose connectors, abbreviated UFL, also known as IPACs. Now, these are the ones that are found. This is literally an Intel Pro Wireless 2200 Wi-Fi card. These connectors are not rated for more than 50 insertions. They're low usage. Once you plug them in, don't remove them. So it'd be a good idea if you want to have a Wi-Fi card. Like, here's my tablet, which you guys see often. I've built in a reverse polarity SMA on each side, and here's a simple, crappy rubber duck antenna. So I have an antenna. And here's the adapter that goes from reverse polarity SMA to N. So I can use big beefy LMR 400 on little itty bitty crappy reverse polarity SMAs. Okay, I've tried to explain as much as I can off the top of my head. I'll put a lot in the show notes. I'll put a lot of pictures up. But let's get on to the mod process, shall we? Here we have typical soldering stuff. We've got 35-watt iron, solder, desoldering braid, basic tools, cutters, needle nose pliers, angled needle nose pliers. Got a couple pair of tweezers, got a couple of screwdrivers, got some kind of, you know, box cutter, razor blade, whatever. Go slit your wrist, go ahead and die, I don't care. We got our 2.4 gigahertz security camera receivers, and we have some LMR 195 coax. That's going to be the prime coax of choice for a lot of the segments. And here is a female panel mount end connector. And here's a crimp-on female reverse polarity SMA for LMR 195. When you get your coax, make sure that you get the proper connector for crimping on. I'm not going to get into the process of using the crimpers. There's plenty of information on the internet. I also did a segment on Amateur Logic, I do believe episode 12, on making your own homemade crimpers, so you don't have to go out and break the bank. But anyway, what I'm going to do is I'm going to crimp on. Well, first I'm going to solder a length of this inside the RF box of this receiver. Have a short length of cable leading into this female connector. This female connector will then be put inside of, like, the entire thing will be put in some kind of case once the design is finished, and that is that. Now you have to remember that radio acts like water in a very weak sense that if there are any holes or any gaps anywhere whatsoever, if you have a break in the shield of your coax, signal will leak out of there. Now, with all of that said, let me explain the RF box. Now, this is a 2.4 gigahertz video receiver made by X10. It had a panel antenna over here, but it broke. I think this coax is LMR 100. I can't be sure. And because I'm not sure, I can't order the proper crimp-on connector. Once you crimp a connector, there's no uncrimping it. That's the end of the story. Now, yes, you can use this coax right here and solder your center conductor right in like so, but how are you going to get that shield to make sure that it shields the outer signal? You'd have to kind of bend and flex and solder the coax. Here, let me see if I can get a better connector. You'd have to solder it like that, which is explicitly what I've done in my other scanner. But this isn't the appropriate way of doing things. It's not a good idea. The best way of doing this is either running the coax directly into your antenna, like they did here. This just solders directly into the antenna, or replace the coax with a known, better form of coax with the appropriate radio connector. So this is one of my earlier model scanners that I did all my experimenting on. That's why all the crap is hanging off of it and it looks like crap. But anyway, they have these solder points that have these little wires that hold the shield on. So using your soldering iron, desolder that off. And here's the inside of the box. Inside of this box, if you notice, let me see if I can get a good shot, you can actually see the center conductor and the shield. Now this entire box is a radio shield. Metal reflects and contains radio waves. So when I put this top panel on, this isolates everything inside. It's shielding because this circuitry is very susceptible to interference. So what I'm going to do is I'm going to carefully desolder the center conductor, desolder the surrounding shield, and take this off. Using a razor blade, I peel back some of the outer conduit, and I shave back some of the shielding, and I've taken the signal wire, and I've pre-tinned it, and I bent it at a small angle so it'll match up with my circuit board, and I've pre-tinned the outer shielding. Now, the hole in the side of this box was too small, so while I was off camera preparing this, I had to use my drill to make the hole a little bit wider. So, see how that fits directly on that nice snug little signal wire? And because it's pre-tinned, all I've got to do is take my iron, tack it on, there you go, there's the signal. Then you go and take some solder, everyday solder, and because it's the coax is pre-tinned, that'll stick nicely. And there's your shield. That's it. Now you've just modded that with an however long length of LMR 195 cable, which you can either directly solder into an antenna or terminate with a connector, which is what I'm going to do. Now it's just a matter of putting the RF box back on. Me, personally, I found that leaving the RF box top plate not soldered down has absolutely no effect on the performance of the scanner. So you can just push that down, and yeah, I'm lazy. I don't want to put it on all the way. Just whatever. There we go. It's on. Shut up. Go away. I'll give you a quick rundown on how to crimp stuff. The first thing you have to do is put on this little tubey thing. This is called the crimp collar. Second thing you have to do is you have to peel back this outer insulation to the length of your connector. Then you have to fold back all of your shield. This right here is called your dielectric. It's covered in some aluminum foil. So when you cut this, so you can put on the center conductor pin, like so. Make sure that they're not grounded. Make sure they're not touching. So visual inspection of that. What I like to do is I like to cut this back and then try to make sure that the center pin fits. Then I pre-tin this with a little bit of solder, and then just like so. There you go, and you get that soldered on. Now make sure you don't have any solder spikes around that. You might have to go and take a file or some desoldering braid to clean that up. There we go. Good as I care to get it. Okay, so we got the crimping collar on, we pulled the shielding back, we exposed some of the dielectric, and we trimmed back some of it so we can crimp or solder on our center conductor. Then we take our jack, and we cram it on, make sure it's in there nice and good. We fold our shielding back up and over, like so. We take our crimping collar, put it around like so. Now would be a good time to take a razor blade and trim all of this off, but for time's sake, we're just going to go and take, oh, there we go, our crimpers. We're going to put this in the proper slot, and we are going to give it a squeeze. There we go, crimped on. Now it's just a matter of taking your mounting hardware that came with it and mounting this to whatever box you want. There you go. Now this process of modding gear will apply for practically anything, and later on we'll get into different devices like USB sticks and PC MCI cards and whatnot, but that's it.